Professor, help! Please help! I need your expertise.
Is it related to mathematics?
Yes, it's related to numbers.
John, you've become more sensitive to numbers, haven't you?
Yes, but this case is too complicated. It involves numbers, graphics, symbols, and English letters.
So, John, you don't know how to investigate if the case is about graphics, numbers, and English letters.
Let me explain it to you. The case involves a dog of excellent pedigree. He went missing from his owner's home last night. The owner told the police that he went to a party in the evening. He shut the doors and windows before leaving home, but when he returned, he found that his dog was missing. What's more, the owner told the police that he received a mysterious cartoon drawing in the mailbox before his dog was stolen. The first part of this picture is of a thief stealing a dog. The thief was obviously expressing his intentions. In the second part, there are a series of symbols followed by two mathematical problems, one involving addition and the other multiplication in the third part. Both are symbol operations in vertical form. I can't figure out the meaning of the last two parts.
I think the thief was informing people of the date that he was going to steal the dog.
How do you know that, Professor?
Thieves who deem themselves smarter than police like to announce their crime in advance. They challenge the authorities by leaving clues in the crime scene.
When did he leave the crime scene? What are these graphics and expressions saying?
Try and find the answer.
Well, what do these graphics and expressions mean? I don't have a clue. Professor, please give me some advice.
Each symbol represents a number. The series of numbers represents a code.
So what's the code?
If we find the value of these numbers, then we'll find a code too.
But how can we find the values of these numbers?
When solving mathematical problems, we can start from the easiest part first. Inquiry activity.
From my observation, star plus star is still equal to star, which means star should be 0 in this 3-digit vertical addition problem. In the tens column, triangle plus triangle is equal to star. Since star is 0 and 5 plus 5 is equal to 10, triangle is 5. But I still have no idea about the operation in the hundreds column. So what do we do next, Professor?
Why not try the long multiplication problem?
In this 2-digit long multiplication problem, diamond pound times diamond is still equal to diamond pound. Therefore, diamond is 1. Moreover, since the resulting units digit of pound times pound is still pound, we can list all its possible values and eliminate the ones which are incorrect. Pound may be 0, 1, 5, or 6. Star is 0, diamond is 1, and triangle is 5 as already solved for with the addition problem above. So pound must be 6.
John, you got some ideas now, haven't you?
It's obvious that 16 times 16 is equal to 256. 16 times 6 is 96, so square is 9. The sum of 96 plus 160 is 256. Therefore, arrow is 2.
John, you've almost found a code. Keep going.
Let me finish solving this 3-digit addition problem. Which number equals 9 when it's added to itself? In the tens column, 5 plus 5 is equal to 10. So 1 is carried forward from the tens column to the hundreds column. Therefore, circle is 4. From the symbol operations, we now know circle is 4, triangle is 5, star is 0, square is 9, diamond is 1, pound is 6, and arrow is 2. Matching the symbols with numbers, the code is 260514. But what does 260514 represent?
The answer is quite obvious.
260514.
When was the dog stolen?
26th of May 2014. Yeah, 260514 represents the date of the crime. The thief informed the owner in advance that his dog would be stolen on 26th of May 2014, but the owner didn't understand.
This thief is playing mind games with the police. Try and tackle this criminal mastermind using your logic and your reasoning skills.
Well, I just want to bring the dog back to his owner.
John, go find some more clues.
Professor, we found a piece of paper where the dog sleeps. There's a clock and some numbers and letters on it. It was left for the owner.
This series of number is not ID number, telephone number, or bank account number. With a clock, it seems like the thief is informing us what time he left the house.
Professor, what time did the thief leave?
The answer you're looking for could be found by solving these two-letter operation problems.
Let me try to use the strategy I applied in the previous problem-solving activity. In these addition and multiplication problems, the easiest part to solve first is the addition problem. N plus n is equal to n, so n is definitely 0. If a plus a is equal to n, and n is 0, a must be 5. The sum of t and t is a. If a is 5, t may be 2 or 7. There is no further information to decode the series of numbers. Let's solve the multiplication problem. In this two-digit multiplication problem, the product of WE times W is WE. W must obviously be 1. The number in the units column for the multiplication of E and E is 1. There are two possibilities for the units column being 1. That is 1 times 1 and 9 times 9. Since W is 1, E must be 9. The product of 19 times 19 is 361. Then I is 3 and V is 6. Using E as 9, the result of the sum of L and L is an even number. Also, 1 is carried forward from the hundreds column to the thousands column. When the result of L plus L is equal to 9 minus 1, L is 4. Previously, we found that T may be 2 or 7. Since 1 is carried forward from the hundreds column to the thousands column, if T is 2, 2 plus 2 is equal to 4. The result doesn't make sense. Therefore, T is 7 and not 2. This series of numbers is not an ID number, bank account number, nor telephone number. So what is the meaning of this series of numbers?
Try to relate the letters with the numbers.
What do you mean, Professor?
I mean, reverse thinking. In this case, the letter represents the numbers, and the numbers represent the letters.
Right, reverse thinking. Let's try matching the numbers with letters. We will leave at 9. Yes, the thief left the crime scene at 9 o'clock.
John, you now got some new clues.
Why did the thief leave so many clues? Does he want to get arrested?
A thief who thinks he's smarter than the police would often play mind games and challenge them.
Knowing the date and time of the dog theft doesn't help. We still don't know where the dog is, let alone arrest the thief.
Don't be disappointed. Don't be outsmarted by this thief. He did so well in the previous mathematical inquiry activities.
Professor, I'm sure that I can find the dog. Professor, the owner received a mysterious message. There's a geometric graphic on it. Analysis by the Criminal Identification Bureau indicates that there are no fingerprints or any other clues.
According to my observation, analysis, and hypothesis, I believe that the thief intended to inform the police of the dog's location with this geometric graphic.
Professor, how did you come to this conclusion?
Let's take a look at this graphic. There's a vertical line, horizontal line, and diagonal lines from the top left to the bottom right, and the top right to the bottom left. They represent the 8 major directions. Also, at the top of this circle, there's a true bearing at 12 o'clock, the north position. I'm quite certain that the thief is going to tell you the location of the dog.
How do we find the bearing that will lead us to the dog?
Solve this 8 by 8 square grid question. Then you'll get the answer.
What? How do I solve this 8 by 8 square grid question?
For problems with incomplete information, and those are not concrete nor stereotypical, we can solve it by standard algorithm. You can also use try and error strategy.
I'm guessing the secret behind this 8 by 8 square grid question for the bearing to the dog's location must be a number. The bearings of 32 or 64 degrees may not be right. In our city, the bearings from 000 to 180, there are only cliffs in the sea. How can the thief escape if he is found? I don't think the thief would be stupid enough to let the police arrest him there.
John, you're so correct in your testing of the outcome and hypothesis. Your evaluation of the hypothesis is also accurate.
Let me try another way. I will count the number of squares in this picture. 1 large square and 64 small squares. That's a total of 65 squares.
65 squares. Are you sure?
I'm not sure. It seems I've left some squares out. Also, 65 degrees is less than 180 degrees. It doesn't make sense.
Please be careful and patient. Keep trying to solve the problem.
Okay, let me try and count the number of squares systematically. I'll start from this simple pattern of squares first. This is a 2 by 2 square grid that is 1/8 of the original square grid. There are 4 squares with a length of 1 unit each, and 1 square with a length of 2 units. There are 5 squares in total in this 2 by 2 square grid. I still don't have any ideas. Well, let me try a 4 by 4 square grid, which is 1/4 of the original square grid. In this 4 by 4 square grid, there are 16 squares with a length of 1 unit, 9 squares with a length of 2 units, 4 squares with a length of 3 units, and 1 square with a length of 4 units. There are 30 squares altogether.
John, now you can simplify the problem and find a solution. Do you have any ideas? Can't you find out some rules? How many squares are there in this 8 by 8 square grid?
16, 9, 4, 1. These are square numbers. Each square number is formed by the square of the consecutive numbers starting from the natural number 1. In the 2 by 2 square grid, 5 is the sum of the first 2 consecutive square numbers. In the 4 by 4 square grid, 30 is the sum of the first 4 consecutive square numbers. If I project this result for this 8 by 8 square grid, the total number of squares is the sum of the first 8 consecutive square numbers. In this 8 by 8 square grid, the number of squares is the sum of 8 squared in descending order to 1 squared. The sum is 204. There's a total of 204 squares in this 8 by 8 square grid. By counting, there are 64 squares with a length of 1 unit, 49 squares with a length of 2 units, 36 squares with a length of 3 units, etc., etc. The result from counting is the same as the result from induction.
John, you're so smart. You can work out a general rule by observation and induction in a given situation. You also did well in carrying out an inquiry activity in mathematics.
If 204 degrees is the bearing, that means the direction to the dog's location is 204 degrees. Professor, do you agree?
I agree. That is your job to investigate and mine to elaborate on mathematical concepts.
204 degrees. I think I know where to go.